Hi everyone, let's try some correlation and regression on Excel. And we're going to do this on real data. So these are two midterms I gave to a math class that I taught. Each test is out of 150 points. And they're matched pairs. So student number one got an 80 on test one, a 75 on test two. There were 46 students who took both tests. All right, now for the correlation coefficient, uh, the command here is equals correl, C-O-R-R-E-L, and then you can put these in either order, either the cells containing the X's and then the Y's or vice versa. It doesn't matter which order you put these in. Okay, but you have to cover both columns. And the correlation coefficient is about 0.7, right? So fairly strong, fairly strong. And remember, R squared is the coefficient of determination. Okay, about 51%. Okay, again, so R was about 0.7. Okay, R squared, which was the coefficient of determination. All right, so that was about 51%. So that means that about 51% of the variation in the midterm 2 score is determined by the midterm 1 score and the regression line. So where is the regression line? All right, so you need the data analysis toolpack on Excel. On my Mac version, you go to, you go to Tools actually, Tools, and then Excel add-ins, and then make sure that analysis toolpack is clicked on. Right, and then you can use commands like linest. So linest, and then now be careful. You put the y values first, comma, and then the x values second. So here I have the B column first and the A column second. Right, and then this value here is the slope. This here is the y-intercept. Okay, so it's like y equals mx plus b. Follows that order. Now, a tutorial is available on YouTube, not by me, but by someone else. But what if we want a scatter plot? Okay, so for a scatter plot, I'm going to go ahead and highlight both columns. All right, I go to Insert. Let's see, this bubble. Okay, this actually a scatter thing here, right? XY scatter. Okay, I'll pick this first one. All right, so here we have a chart. And on the YouTube video, whose URL I have on my spreadsheet, you can check about on more details like titling and so forth. So here's a scatter plot, midterm 2 versus midterm 1. And for the linear regression line, you can go to Add Chart Element, Trend Line, Linear, and they'll get you the linear regression line. So this linear regression line is in fact the line. I'll move this around. It is in fact the line. Regression line is given by y hat equals, actually it is the population regression line, population linear regression line. So y equals, it's a model that is basically the best linear fit for this population data. So it's y equals, okay, the y-intercept is 37.529 about, plus, okay, the slope is up 0.748 times the x, all right? So that's the regression line. Now, actually, I'll move this aside. I use that for predicted test 2. So if I just knew the test 1 score, and let's say that I lost the list of test 2 scores, shame on me, I better recover it sometime, all right? Then here's my prediction for how you scored on test 2, okay? Just based on regression. And this incorporates concepts like regression to the mean. Now, let's say I find the test 2 scores. Well, here's the error in my prediction in terms of a raw score. So in this case here, I predicted a 97, you got a 75. Okay, so your score was actually 22 points below what I predicted for you. So this residual here indicates how your score was different from my prediction. Now, because the tests were out of 150 points, here's the percent error. And by the way, if you were to add up all these errors, okay, you're going to get basically 0. The errors basically add up to 0. The least squares regression line has a property that's going to minimize the sum of the squares of all these errors. For more information, you can go to data analysis. You need the to install the analysis tool pack first to get to here. All right, regression. Okay, now input the Y range. You can move your cursor over the corresponding entries here. All right, and then for A, I think I've already done that actually, but you do the same thing for the A column. All right. And in this new worksheet, wow, you have a lot of information. The correlation coefficient R is under multiple R here. Again, it was about 0.7, right? R squared is here, right? It was about 0.51. So about 51% of the variation, remember, about 51% of the variation in the midterm 2 scores is determined by the midterm 1 score, X, and the regression line. All right, that corresponds, okay, so 51% of the variation midterm 2 is explained by all of that. The other 49% can be referred to as unexplained variation. All right. Okay. And over here, see here, the linear regression is conducted. We have the y-intercept here about 37.5. We have the slope about 0.748, just like what we got from LinEst. And we have a lot of other information here, okay, including information that can tell us whether the slope is 0, okay, doing a hypothesis test to see if the slope is 0, something like that. Okay, so here, the p-value here indicates that's very unlikely that the slope is actually 0. You can have things like confidence intervals. So lots of information over here. ANOVA has more to do with independent samples, but it is true that a t-test with independent samples will correspond to an ANOVA, a basic case of ANOVA. Wow, lots of information here, but the basics were indicated over here. You can do correlation and linear regression on Excel, but it may be a bit clunky, but it's there. If you have Excel, it's all there. Okay, StatCrunch may be cleaner, but it's all there. Here's a scatter plot. The trend line here is the linear regression line. It minimizes the sum of the squares of the residuals. All right, bye-bye.